Hello everyone, and welcome to the Logistic Regression with Python lecture. I'm really excited for this lecture because we're going to be working with a Titanic dataset. This is a very famous dataset, and it's often a student's first step in machine learning for classification. We're going to be trying to predict the classification, survival or deceased, for passengers who were on the Titanic. And we're going to be using a semi-cleaned version of this Titanic dataset, and the dataset original source is actually from kaggle.com. Let me go ahead and briefly explain what kaggle.com is. I'm going to go ahead and jump to the website in my browser. Okay, so here I am at Kaggle, or kaggle.com, depending how you pronounce it, but it's kaggle.com. And basically, this is a data science hosting website. It has two or three main aspects to it. The first aspect is one we're actually already familiar with, which is the datasets aspect. Basically, this is a website that can host datasets. So for instance, if you're interested in one of these datasets, you can kind of scroll down here, check out some of these datasets, such as airplane crashes since 1908. You can go ahead and click on this link, and it'll load up the dataset, a way to download it, and some information on that dataset. For instance, here you can go ahead and click download the dataset and read a description of the dataset, and sometimes it even has open-ended questions for you to answer, just as a curiosity. The other aspect of this website is the competitions page. If you go ahead and click on the competitions page, it'll take you to a list of all the active competitions. And basically, this is a place where companies can post their own datasets with their own problems and ask either a single person or a team of people to compete for a monetary prize in order to solve their own real company problems. Sometimes they're offering money, other times they're offering jobs at their corporation. So you'll see things such as Facebook post a challenge on this website, and if you do well in the challenge, they'll actually ask you to interview at their company. And other challenges are just for knowledge. So you can see these simpler challenges here are actually just knowledge-based challenges. And the one we're going to do is the Titanic Machine Learning from Disaster Challenge. And this is the basic source of where we're actually going to be getting our data from. Now this data has actually already been downloaded for you and is part of the whole package you downloaded with all the notebooks. Let me go ahead and show you where to find it. If you go ahead and jump to the Machine Learning Sections folder under Logistic Regression, you'll see some files here, and the Titanic Test CSV and Titanic Train CSV files are the data sets we're going to be working with. So go ahead and use these two CSV files that have already been downloaded for you. And the notebook we're going to be using is Logistic Regression with Python. Later on, we'll show you how to do the project, and then we'll show the project solutions. But for right now, let's go ahead and jump straight to a new notebook. Or you can go ahead and follow along with the lecture notebook, but I'm going to go ahead and get started and do some machine learning with this Titanic dataset. Alright, I went ahead and cleared the toolbar and the header just to give us some more room. Let's go ahead and get started with our imports. I do pandas as PD, numpy as np, and then let me go ahead and do my visualization imports. I'm going to say matplotlib.pyplot as PLT. I like importing Seaborn as SNS, and then since I'm using the notebook, I have to say matplotlib inline. Perfect. What we're going to go ahead and start doing is by reading in the Titanic Train CSV file into a pandas data frame. I'm going to create a data frame called train and say pd read CSV, and I can actually just start typing Titanic, and if I click tab here, it will autocomplete to the options available for me. So in this case, I want to do this Titanic_train.csv. Run that, and then I'm going to go ahead and check the head of the data frame just to get an idea of what's in there. It looks like we have a passenger ID column, a survived, which notice it's a 0 or 1, so 0 if they did not survive, 1 if they did survive. P class, which is the passenger class. So the passengers can be in first class, second class, or third class, depending on where they're in the ship. There's also the name of the passenger, the sex or gender of the passenger as a string, male or female, the age of the passenger if they happen to know it, and then this SIB-SP, that indicates the number of siblings or spouses aboard, and then PAR-CH indicates the number of parents/children aboard. And then there's a ticket number, a passenger fare, how much they paid for their ticket, and if we go ahead and scroll over to the right, we'll see a couple more columns. There's cabin, which is the cabin they were in, if it's known, and then embarked, and it's a port of embarkation, so C for Cherbourg, Q for Queenstown, and S for Southampton. All right, those are the basic columns. Let's go ahead and begin with some exploratory data analysis. Now, a lot of times, you're going to have missing data. What we're going to go ahead and do is use Seaborn to create a simple heat map to see where we're missing the most of our data. I'm going to go ahead and do this. I have my training data, and if I say is null as a method on it, let me go ahead and just show you what this looks like, at least what part of the output looks like. Notice the data frame's too big, but you basically get booleans of true and false. So you'll get a false if it is not null, or a true if it is null. So remember back to that very first cabin, it was NaN, so it was unknown, it was null, so it went ahead and put true there. With this sort of data frame, I can actually make a heat map. So I'm going to say this, I'm going to say sns.heatmap, and then I'm going to add a few more arguments so we don't get a bunch of tick labels. I will say y tick labels is equal to false. I'm going to go ahead and say C bar is equal to false because we're not doing an actual color bar. And then I'm going to finally pass in CMap as Viridis. Let's go ahead and see what this gives us. All right, so notice what I've created here. I've created a heat map of those Boolean values, those true and false statements. And due to this CMap, this color mapping, every yellow dash here basically stands for a true point, where true it was null. So we can just glimpse now at our data from a very far bird's eye view and check out that yes, we're missing some age information, we're missing a lot of cabin information, and we're missing just essentially one row of embarked. Roughly about 20% of that age data is missing, and the proportion of age missing is likely small enough for reasonable replacement with some form of imputation, meaning I can actually use the knowledge of the other columns to fill in reasonable values for that age column. Looking at the cabin column, however, it looks like we're just missing too much of that data to do something useful with it at a basic level. We're going to go ahead and probably drop this later or change it to some other feature like cabin known 1 or 0. Let's go ahead and continue on by visualizing some more of this data. We'll come back to this problem of dealing with the missing data later on. What we're going to go ahead and do is a couple more plots to just do some exploratory data analysis at a visual level. I'm going to go ahead and say SNS set style to white grid, just because I personally prefer that style. I think it looks a little better. First thing I want to do is just get a count of who survived, who didn't survive. For a classification problem, it's always a good idea just to see the ratio of the actual target labels. And we can do this with a simple count plot. I can say SNS, dot count plot. And then I'm going to just go ahead and set X to the survived column. Set my data to train. And then I'll go ahead and just run that. And here we can see I have quite a few more people that did not survive versus 1, which is survived. Looks like around 550 of these passengers in our data set did not survive, and it looks like about, in this particular training set, we have about 350-ish, maybe a little less, that actually did survive. So it looks like we have less survivors than non-survivors or deceased. What we're going to go ahead and do is create another count plot of seeing survival with the hue of sex. And I can actually just add this in, so I'm going to say hue is equal to sex, and this is going to add some coloring so we can actually tell by gender the survival rates. Okay, and I'm going to go ahead and add a palette argument to make this a little easier to see. I'm going to do rd bu underscore r, lowercase r. Now you don't have to do this, this is just for coloring, but that way male is blue and female is red, or a light pink color. This makes it a little easier to read. Okay, looking at this plot, now I can really tell there's a trend here. It looks like people that did not survive were much more likely to be male, and people that did survive were almost about twice as likely to be female. And we're going to see that trend come up later when we're looking at the factors and coefficients of what led to someone's survival. Let's go ahead and continue exploring the data by changing this hue to the passenger class. So I'll go ahead and say, instead of sex here, P class. So for the passenger class, and I'll go ahead and remove this palette. We'll go ahead and just use the default palette, which is blue, green, and red. Okay, again, looking at this, we can kind of tell the trend here on survived versus not survived. It looks like the people who did not survive were overwhelmingly part of the third class, or the lowest class. That was the cheapest to get onto. And it looks like more or less the people that did survive were leaning a little more towards the higher classes, 1 and 2. But we'll also have to see how many people are actually in the passenger class, or per passenger class, when we're doing that analysis. Let's go ahead and just get an idea of the age of people on the Titanic. To do that, I can go ahead and do a distribution type plot. I'll go ahead and say SNS, this plot. I'll pass in the age column. Remember, this plot just takes in an array of values. And for now, I'll go ahead and say drop NA, since I don't want to have those null values messing up my distribution plot. I'll set KD equals to false, because I just want to see a histogram of those values. And let me go ahead and set bins to something a little higher, such as 30. Let's run that. Okay. We get an interesting, what appears to be almost bimodal distribution, where you have quite a few young passengers towards between ages 0 and 10. So there's quite a few children in that zone, but then after that, you can see it starts to get an average age towards maybe 20 or 30, somewhere around there. So there's quite maybe a skew towards younger passengers. And as the older you get, the less representation you have on board. Okay, let's go ahead and show you another way you could have made this plot. If you wanted to, if you weren't a huge fan of Seaborn, you could have also done this directly off of the age column, doing something like dot plot hist, and Panda's own visualization can do this for you. And you can also add more bins if you want to, so you can say bins 35 just to get kind of a similar looking plot here. Okay, depends what you want, what you're trying to do, it's up to you. Okay, let me go ahead and go back to Seaborn real quick. Let's go ahead and explore some of the other columns. Just to get a reminder of what those columns are, I'm going to go ahead and call info. Okay, we've already checked out the survived column quite a bit. We've seen P class, the sex column, age column. Let's go ahead and explore that SIB SP. That was the number of siblings or spouses on board. Let me go ahead and do an SNS count plot. Set X equal to that column, SIB SP, and tell Seaborn my data that I'm going to use is that train data frame. All right. Now looking at this plot, I can basically immediately tell that most people on board did not have neither a children or a spouse on board. And if we look at the second most popular option, it's just one, which is actually most likely to be probably a spouse versus just having a single parent with 1 children on board. So those numbers pretty much make sense. You have a lot of single people on board. They don't have a spouse. They don't have any children on board. Probably those are the men in the third class. And after that, you have the second most common type of passenger in our data set is someone with just one either sibling or spouse, and that's probably going to be their spouse, so couples on board. Okay, another column we haven't actually explored yet is the fare column. Let's go ahead and take a look at how much people paid as a distribution. I'm going to go ahead and do this with pandas. I'll say train fare, and remember if we take a look at that, that's basically just their fares, what prices they paid. I'll say .hist to call a histogram. And let's go ahead and just run this and see what we get. Okay, immediately we see that there's quite a wide range of values, but most of the distribution seems to be somewhere between 0 and 100. To give a little more detail, I'm going to increase my bins size to 40. And then we can also kind of stretch it out by passing in fig size to maybe a 10 by 4. Okay, now I can get a higher distribution or a higher level of detail in this distribution. So now it looks like most of the purchase prices are between 0 and 50. So it makes sense that things are distributed towards the cheaper fare tickets because, as we've already seen, most passengers are actually in the cheaper third class. And keep in mind, these are fares back when the Titanic was around. And that was in 1912, so these prices haven't been adjusted for inflation. Okay, let me go ahead and take a quick moment to show you an example of how we could have done this sort of plot with cufflinks, in case you really like the interactive plots. We could have said import cufflinks as CF, and then told cufflinks that we want to operate offline. And then we go ahead and essentially do the exact same thing. So grab the fare column off a train, and then we just say iplot in order to see this in our plot, and say kind is equal to hist. We can specify some more bins, and then see this run. And now I can go ahead and zoom in and check out these bins myself. And I can add more bins if I wanted to. Put in 50 bins, zoom in, see where I'm most interested, and get the actual counts and exploit the data that way. Just another tool for you to use if you want a more interactive experience with this data. Lots of stuff you can do with Python. It's just a very powerful language, and there's lots of great libraries for it. Okay, I'm going to go ahead and comment that out. So let's go ahead and end this lecture here as finishing our exploratory data analysis. So we just went ahead and kind of explored the data without really knowing too much about it beforehand, just to try to grab some contextual information from it. We went ahead and saw the distribution of fare prices, saw the counts of siblings versus spouses on board, made the assumption that most of them were probably single based off this count, or just had one spouse. We went ahead and checked out the age distribution. And then we also looked at survival versus passenger class and survival versus the sex or gender. And we can go ahead and take a look at that again. Whoops, that should be capitalized. And we can see that again, that mostly men are in the non-survival group and mostly female are in the survival group by a ratio of 2 to 1 female to male in the survival group. And then we also saw that we have quite a bit of missing information, and we want to figure out how can we deal with the age column and how can we deal with this cabin column. All right, we'll go ahead and tackle how to deal with that missing data in part 2 of this lecture series. Thanks everyone. Go ahead and explore the data a little more on your own if you're still interested in making some more visualizations, but I'll go ahead and see you in the next lecture.